Hi students, hope you have gone through the last video. Last class we studied the structure of human eye, we studied the different parts of the human eye and what are the functions, how each part helps us in forming a clear focused image on the retina. Okay, this class we are going to study certain defects of the eye wherein you are not able to focus on things properly. Things becomes blurry. We are not able to see sometimes far off things or sometimes nearby things. So such type of defects are called as refractive defects of distinct vision. Last class, we also studied something about power of accommodation. What is power of accommodation? It is the ability of the human eye, or we can say basically ability of the focal length to ability of the lens to change the focal length according to the requirement. According to the distance of the object, the focal length will change its curvature with the help of ciliary muscles, and as the curvature changes, focal length changes. Hence, we are able to focus on things at any distances. Now, when due to certain reasons, when the lens loses this ability, okay, to make these finer changes in the focal length, defects arise. Now, let us see what type of defects we are going to study. So, in this class, we are going to study myopia, which is also called as nearsightedness, hypermetropia or hyperopia, also called as farsightedness, presbyopia, cataract, and astigmatism. So what do you mean by myopia? Myopia means nearsightedness. As the word says, nearsightedness, you can see nearby things, can see nearby, cannot see far off. Cannot see far off things, right? So normally very common in students. So as this girl, the students, they are not able to focus on the word. Everything becomes blurry. Nothing seems very clear. Students go through myopia. The eye defect which students go through is called as myopia, wherein they are not able to see far off things, but they can see nearby things. Right? So that is myopia, which is also called as nearsightedness. Nearby things can see, far off things cannot see. Now, nearby object, obviously it is focused on the retina. Okay, if you see the spoon, it is focused on the retina, and anything which is focused on the retina, we are able to see that thing clearly. But for example, just imagine the spoon becomes here. Okay, so when the spoon is far off, what will happen is, see, distant object. Now, what will happen when these rays from far off, or more far off, already parallel rays are going to come. So when these parallel rays come from far off things, they get converged at a point which is in front of the retina. So if you can see these objects, the image of this object is formed in the front of the retina. As the image is formed in the front of the retina, we are not able to see these objects clearly. Hence, the images become blurry and we cannot differentiate properly between the images, right? So what can be the reason of it? This is a normal eye, okay? And if you compare this with the myopic eye, one of the main reasons for this is elongation of the eyeball. So when the eyeball elongates, distance between the retina and the lens increases. So as this distance increases, your image which was supposed to be formed at a point on the retina, this image gets formed in front of the retina over here, right? So first and the foremost reason is elongation of the eyeball. Secondly, excessive curvature of the eye lens. Excessive curvature of the eye lens, that means when eye lens, due to certain reasons, loses the ability to become thin. Okay. Excessive curvature, that means it will be always bulged out. Always bulged out, that means focal length always decreased condition. Decreased condition, you can only see nearby things, you cannot focus far off things. That means it cannot go from this bulged position to a thin lens. So thin lens means more focal length means you can focus on far off objects. This is the main reason. Elongation of the eyeball, excessive curvature of the eye lens. Now, how can we correct this condition? This condition is corrected by using a concave lens in front of our eye lens. What is a concave lens? A concave lens is a diverging eye lens. So when light rays from infinity pass through this, first they will diverge, then they come in contact with the eye lens, then they get converged. Okay, so that means over here, what are we doing? We are diverging the light rays and focusing it on the convex eye lens. That means we are increasing the diverging power over here, because in a myopic eye, converging power was increased. So we want to decrease the converging power. So for decreasing the converging power, we have put in a concave lens in front. Concave lens in front of the. Now, can you tell me, do you remember what is the focal length of a concave lens? The focal length of a concave lens was negative. Okay, focal length of concave lens is negative. So as the focal length is negative, what will happen? Power of this lens, which is kept in front of the eye lens, power will also become negative. P is power. So power of this concave lens is also negative, right? So normally when the doctor tells you that you have a power of 2, okay, so that means if you are a student, a myopic eye means we need to put in a concave lens. So that means your power over here will be -2 diopters. Okay. Now, if this is a little comparison far point of the myopic eye. This is the myopic. This is the normal eye. This is the myopic eye. The image formed over here is in front of the lens. What do? We use a concave lens. This is the correction part. Concave lens. Concave lens is diverging. It diverges the light rays and then focuses it on to the convex converging lens of the eye. And now the image is formed on the retina. So in this way, you are able to see a proper image of the far off object. Now, the second type of eye defect or the refractive defect, that is called as hypermetropia. Sometimes it is also called as hyperopia, also known as farsightedness. Farsightedness, that means you are able to see far off object, not able to see nearby objects. So if you can see this girl, she is not able to focus on some words which is written on the book. The book is quite near to her, right? So you can see far off objects, cannot see nearby objects. So this distant objects are seen, nearby objects are not seen. In which condition? Hypermetropia. Hypermetropia, that is farsightedness. Okay. So now when you compare your normal eye with hyperopic eye, that means hypermetropic eye, see, in a normal eye, this nearby object light rays will go like this, get converged, images formed in the retina. But now in case of a far-sighted eye, these eye rays, after getting converged, the image is formed behind the retina. Okay, it is exactly, hyperopia is exactly opposite of myopia. What can be the reasons? The reasons can be shortening of eyeball. Shortening of eyeball, that means over there, what was the reason? Elongation. In myopic eye, there was elongation of eyeball. So distance between lens and retina was increased. Here, distance between lens and retina has decreased. Okay, so as the distance decreases, these rays are intersected at a point behind the retina. So the image is formed behind the retina. Secondly, increase in focal length. That means again, the eye lens loses its ability to do these finer adjustments. So the eye lens always remains in a thin stage. Okay, it cannot go back to a bulging stage. So thin stage means more Increase in focal length. Increase in focal length, that means able to see far off objects. More the focal length, more far you can see. Bulging means less focal length. Less focal length, you are able to focus on nearby things, but that ability is lost by the eye. Okay, so that is called as hyperopia, also known as farsightedness. So reasons: shortening of eyeball, increase in focal length. In myopia, what was the reason? Elongation of the eyeball and losing the curvature, ability to contract. Here the ability to relax of the eyelids. Correction of farsightedness. How can farsightedness be corrected? So in case of myopia, we had put in a concave lens in front of our eyelids. Now, in case of farsightedness or hypermetropia, we are going to put in one more convex lens. So when the light rays from a nearby object fall on this convex lens, they will get converged. This is your human eye lens. Now this will again get more converged, and now the image is formed in front of the retina, that means on the retina. So when the image is formed on the retina, we are able to see that particular object. Okay, so now you put in this case, now you put in a convex lens. In case of myopia, you had put in a concave lens. Now, what is the focal length of a convex lens? Focal length of a convex lens is positive. Focal length is positive. Power formula, power is 1 upon f. So therefore, power of a convex lens will also be positive. So normally, people who are suffering from hypermetropia get their spectacles, the power of the spectacles is always positive. People who have myopia, the power of the spectacles is always negative. Myopia is generally observed in students. Hypermetropia is generally observed sometimes in students or children as well, if they have a genetic defect, and sometimes in big people as well. Right? So just a little comparison between myopia and hyperopia. Myopia, nearsightedness, able to see nearby things, cannot see far off things. Hyperopia, able to see far off things, cannot see nearby things. Your image is formed in front of the retina. Your image is formed behind the retina. Reason: elongation of the eyeball. Elongation of the eyeball. Your reason: shortening of the eyeball. Eye lens always in contracted position. Eye lens always in relaxed position. Right? Then corrective eye lens. Corrective eye lens in case of myopia, concave lens. In case of farsightedness, it will be a convex lens. Power of a myopic eye would be negative. Power of a hypermetropic eye will be positive. This is a hypermetropic eye, normal eye, hypermetropia, image formed behind the retina. You put in a convex lens in front, again increasing the converging power. Now image is formed on the retina. So basically, when a 5-mark question is expected on explain the entire defect of myopia or hypermetropia, these diagrams are expected. Very important diagrams expected from exam point of view. Okay. Now the third type of disease that we have is presbyopia. Presbyopia is normally seen in old age adults. Okay, normally it is there in old age, wherein the ciliary muscles become weak due to age. Okay, due to aging, ciliary muscles. What are ciliary muscles? Ciliary muscles are the muscles which holds the convex lens of the human eye. So because of the ciliary muscles, the eye can contract and relax. The eye lens basically can contract and relax. So when these ciliary muscles become weak, the eye lens also cannot contract and relax according to the object distance. So when they become weak, when we lose this ability, that is when we lose the power of accommodation, People with old age, normally they are detected with presbyopia. So presbyopia, distant objects, that means the eye is always in a relaxed position. Eye lens cannot focus on nearby position. That means the eye lens cannot contract, right? So this is what we meant by presbyopia. Presbyopia, cause I have told you, weakening of ciliary muscles. Here again, as nearby objects cannot be seen, the image of the nearby object is formed behind the retina. That means the power of accommodation reduces. Normal eye, presbyopic eye. We know for the normal eye, what is the least distance of distinct vision? It is 25 centimeters. For a presbyopic eye, the least distance of distinct vision becomes greater than 25 centimeters. So it is 25, more than 25 centimeters. We can see objects clearly with up to a distance of 25 centimeters. If the distance becomes less, then the object becomes blurry. But for a presbyopic eye, even at 25 centimeters, you cannot see images properly. These images becomes blurred, right? So for a presbyopic eye, least distance of distinct vision becomes greater than 25 centimeters. Now, why does it arise? It arises due to gradual weakening of the ciliary muscles and diminishing flexibility of the eye lens. Sometimes a person may suffer from both myopia and hypermetropia. Okay, for example, if you are all are students. So now if you have specs, your eye is myopic. Okay, but when you go to your old age in your 50s and 60s, you develop presbyopia. You develop this thing, hypermetropia. Okay, now this condition wherein you have both myopia and hypermetropia, you will have to use bifocal lenses. Okay, what are bifocal lenses? Bifocal lenses are something like this. For example, this is your glass lens. Okay, so this region, this is your concave lens. This region becomes your concave and this region becomes your convex. Now, why is it concave? Because from the upper region, you want to see far off things. So for far off things, you need a concave lens. And this region is normally used to read something or to focus on objects nearby. So this becomes your convex lens, right? So these are your bifocal lenses, consist of both convex and concave lenses. Upper portion consists of a concave lens, facilitates distant vision, and the lower part is a convex lens which facilitates near vision. See, these are the bifocal lenses. This is for distant. Which type of lenses? Concave. This is for nearby. Convex. Now, there's one more condition that is called as cataract. What is cataract? Cataract is basically the whitening of the eyeball. Okay, whitening of the eye lens. Basically, the eye lens becomes cloudy and milky. So when the eye lens becomes cloudy and milky, so if you see a lot of the rays which are coming to the human eye, all these rays are not able to pass through the eye lens. Why? Because the eye lens becomes cloudy and milky. So what happens is the proteins which are there in the eye lens, okay, these proteins starts ossifying, ossification. Okay, ossification means it starts becoming solid. Okay, opaque. It starts converting into an opaque thing. So that's why it becomes. So if you see the comparison of the eye, if you see this and this over here, this whiteness has occurred. This is the milky and cloudiness of the eye lens. It is because of that. So it has partial or full loss of vision. It is opacification of the eye lens. It is also called as ossification of the eye, of the lens of the eye, which leads to decrease in vision. Cataracts are often developed slowly and can affect one or both the eyes. What would happen? The eye becomes milky and cloudy. Symptoms may include faded colors. You are not able to see colors properly, blurry or double vision. Halos around light. Halos around light. That means if this is a ray of light which is coming, you will see small things around that also. That is called halos around light. trouble with bright lights, you are not able to focus properly in bright light as well, trouble at seeing at night, cannot see objects in dim light as well, partial or complete loss of vision. We can restore this vision through cataract surgery. Nowadays cataract surgery has become a very common thing. It's a normal 10-minute surgery, laser surgery, wherein they change the islands totally, because though that cloudy and milky islands cannot be restored back to its original condition. So they put in an artificial lens, and then your condition vision is restored. So if you compare islands and a normal eye and a cataract eye, so see, normal eye, entire full amount of light is reaching the retina. In a cataract eye, because of this clouded lens, only 30 to 50% of the rays of the light rays which are going into the islands gets focused on the retina. So that is why it's partial or complete blindness. Now, the last type of disease that we have, that is called as astigmatism. What do you mean by astigmatism? Astigmatism is a condition wherein you see two images. Okay, people see, like over here, if you see this image and this image, and both of these images are of reduced intensity, blurred images. Intensity is less, and two images are seen. That condition is called as astigmatism. What is the reason for astigmatism? Continuous rubbings of eyes. Okay, what happens is, because of the rubbing of eye, the alignment inside the eyeball, it's disturbed, and because of that, sometimes when these two images are formed, one image can be behind, one image can be in front of the eyelids. So one is behind the retina, one is in front of the retina. So the object appears blurry. It uh, can happen with both far off objects and nearby objects. So this entire condition, when you are able to see two blurred objects of one object, we see two blurred images. That type of a condition is called as astigmatism. Okay, so we studied the different types of eye defects which are there. We studied myopia, which is also known as nearsightedness. We studied hypermetropia, hyperopia, which is also known as farsightedness. Presbyopia, wherein it is same as hypermetropia. Then cataract, a condition wherein the eyelids becomes cloudy and milky. And then astigmatism, where we are able to see two images at a time of one object. Okay, hope you have understood. Go through the entire class, because one question from this part is bound to come in your board exams, be it state board, be it CBSE board, or be it ICSE board. Okay, very, very important. Please learn the diagrams. Okay, normal eye, defected eye, corrected eye, for both the conditions, myopia and hypermetropia. These conditions will be asked. Okay, do the reasoning part, do the correction part. Why is this condition there? That is the reasoning part, and how this condition can be corrected. Okay, fine. Hope you enjoyed. Next class, I will show you how to draw